Section 7-1, Part 4. A two-variable relationship is often represented by a graph. So it makes sense that a relation can be defined by a graph. If the graph of a relation displays points with coordinates that are easily read, you can write the ordered pairs and then use a mapping diagram to determine whether the relation is a function. So see, here we have an x and y axis, like we've been using to graph lines. For instance, let's look at this point. What is the name of this point? The name of this point would be 2. You go from, start at the origin, you go to the right, 1, 2, that is your x value. You go up on the y-axis to get to this point, so that is up to positive 1. So the name of this point right here is 2, 1. Always start at the origin. If you go to the right, that's positive 2 and up 1. Okay? Let's name this point for practice. The name of this point. You go to the left, therefore you're going in the negative direction. So negative 1, 2, 3, my x value is negative 3. So I'd go to the left negative 3 and up 1, 2, 3, 4, positive 4. So to be in this quadrant, which is quadrant 2, you go to the left 1, 2, 3, negative 3, and up 1, 2, 3, 4. So the name of this point's negative 3, 4. So we have already been graphing lines by plotting points. All right, so let's continue on reading. There is a way other than mapping diagrams to inspect a relation and determine if it is a function. All right, so we can use a pencil or a straight edge to represent a vertical line. Place the pencil at the left of the graph, move it to the right across the graph. If for each input value it passes through exactly one point on the graph, then the graph represents a function. Remember to keep the pencil vertical at all times as you move it across the graph. So, let's look at some examples that they have for us. Here they have 3 different graphs, and they want us to determine by using what we call the vertical line test to determine if this graph is a function. All right? So I'm going to take a pencil and I'm going to move it starting on the left. I'm going to move it across A. A you see is a line. Now all the way up this line, there's points on this line. So as I move this pencil or pen across the line, does it ever touch the graph 2 times? Notice my pencil touches the graph once here, once here, once here, once here, and once here. If my pencil or pen ever touches my graph more than once, it is not a function, because if it touches it more than once, it means that the x's repeat. So in looking at A part, this would be a function because my vertical line test never touched my graph more than one time every time I moved it. Now let's look at B. Will there ever be a point where I draw my line, or either I use a pencil going across from left to right? Is there ever a point, or is there ever a line that I could draw vertically that it would touch my graph twice? That's our question. So here it touches my graph once. Here it touches my graph once. Here it touches my graph once. Here's once. But what about here? If I draw a vertical line, how many times does my vertical line touch this graph? It touches it 1 time, 2 times. Therefore, this is not a function. I have used the vertical line test to see that this is not a function. What is the name of this point? The name of this point would be To the right, 1, 2, up 1. So the name of this point is 2, 1. What is the name of this point? Well, starting at the origin, to the right, 1, 2, and down 1. So that would be 2, negative 1. As you see here, my x's repeat. And in order for you to have a function, the x's cannot repeat. So if at any point in time, if I draw all the vertical lines that I could possibly draw, if any of the vertical lines ever touch the graph more than once, it is not a function. Now let's look at C part. Think of me drawing all the vertical lines that I can possibly draw. Do any of these vertical lines ever touch the graph more than once? See, drawing the vertical lines is the same as me moving my pencil. If I move my pencil from left to right, is there points on this graph where my line touches it more than once? No, you see this line touched our graph one time, 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 one time. Therefore, this is a function. But think of all the vertical lines that I could draw on B part. Here's the vertical line. It touched it more than once. Therefore, this is not a function. By the vertical line touching the graph more than once means that the x's repeat. And if your x's repeat, it is not a function. And we call this using the vertical line test to determine if a graph is a function.